Hey, good morning. We are going to be starting up Unit 2 today, starting with some properties of exponents. I'm going to stay in exponents for a couple of days here, doing a couple of different things, so we'll get locked in here. A couple of things with exponents here at the top. Reminders, so we have some of the vocabulary down as we're doing some of this, that 2 to the 5th, the whole thing is a power, 2 to the 5th power, where 2 is our base. It can be a variable, it can be a number, and 5 is the exponent. Now notice, 5 is not the power, the whole thing is the power. 5 is just the exponent. We want to keep those straight as we're moving along. So there are a few examples down here below of how to understand the algebra portion of some of these properties of exponents. And basically it comes down to this. When we're multiplying, okay, the bases have to be the same. Make note of that here somewhere. So like if this were happen to be a to some power and b to some power, I can't put those together. Okay. So for our example, we got 3 squared and 3 to the 5th, both same base of 3. We add their exponents. So it'd be 3 to the 2 plus 5, or 3 to the 7th. Okay. Power of a power is when we have a parentheses and we're taking a power to that quantity. When that happens, we multiply the exponents. So here, 2 to the 3rd, 2 to the 2nd would be 2 to the 3 times 2, or 2 to the 6th. Okay. Just kind of keeping these straight. Make sure you keep this handy as you're starting to do some of the assignment stuff with this, because it'll just help remind you as you get going. Maybe even you write in, add, multiply. Here, power of a product just means that exponent in some way is just going to sort of distribute through to each part inside the parentheses. So here, for instance, 4 times 3 to the 3rd, you could distribute that through. You could get like you did here, or if you multiplied it out. I'm just going to do this because I want to show you something, okay? Just where you have some multiple ways to do things. We're going to really show this in an activity we do here tomorrow. So if I go through, try not to get too much of a glare for those of you at home. Let's turn this down a little bit. So if I do 4 to the 3rd, and again, you're like, hey, how'd you do the exponent thing again? Caret button, that's my exponent button. Times 3 to the 3rd. Oh dear, that's all kinds of bad. I just learned a lesson. Lesson learned here. When you are up in an exponent like I was when I did 4 to the 3rd, I need to hit my right arrow so I can get back down out of there so things don't happen like just did to me there. Okay, you're like, okay, so why is it important I know 1728? Because here's your other option. Let's say instead on this, and I'm just, again, showing to kind of give you some more ways of doing things. 4 times 3 is 12, right? So if I do 12 to the 3rd, 12 to the 3rd, Hardy, I get the same thing. So what you're going to start learning with your exponent rules is, it's not like order of operations where you have to do it in this order or else. You're going to have some options, just to say. Okay, negative exponents. Never in an answer. When you get to the final answer, never, never, ever, never, never going to see a negative exponent. Okay, so how do we fix that? We flip them. Okay? You're like, okay, so what do you mean? So, for instance, if I have a to the negative n, let's use this. 5 to the negative 2nd. Okay? Every number we always have, if it's not a fraction, can be a fraction. How? I can put it over 1. So when I say flip it, it just means that negative value, it's in the numerator now. If I flip it down to the denominator, it becomes positive. And that works. And then I can simplify it and do 1 over 25 or however I want. So let's say it goes the other way. Let's do a second mini example here. So let's say I've got 1 over 4 to the negative 3rd. Same rule. The 4 to the negative 3rd is in the denominator. I would move it up to the numerator. I can put the over 1, but I really don't need to. And that works. I've made it positive, and I can work it out. Quite possibly my favorite exponent rule, the 0 exponent. Anything to the 0 exponent is 1. Now you're like, what do you mean when you say anything? Like anything? Okay, here, 100 to the 0 equals 1. This could be ABC squared to the 0. And as long as all that stuff in the parentheses is to the 0, it still equals 1. So variables, numbers, doesn't matter, still would be 1. Okay, quotient we're going to subtract. Now, I'll talk a little more about this as we do some of the other examples. I always am going to be a fan with my exponents of doing bigger minus smaller. I know some books and some things like this will say numerator minus denominator every time. That can get you into doing more steps sometimes. We'll chat about that more as we go, but the general rule is you're subtracting exponents. 5 minus 2, and then I'd get 3 to the 3rd. Okay. And power of a quotient, simply like power of a power and quotient of powers put together, distribute that exponent on the outside of your parentheses, the outside of your quantity to both places, and then simplify as much as you can. So when we're doing these, and what I would suggest you try, because you notice we've got them sectioned off into portions down here by whatever property it is, that I would do the first one and then you would hit pause on me and you try to do the second one and then watch and see, are you doing it right? And we can start learning some stuff here before we ever get to the practice. It's just kind of an extra layer of learning that's in there. So product of powers, what am I doing? Well, I see it's multiplying. So I see I'm going to be adding my exponents. Okay, 4, that is not an exponent. That's a coefficient. There are no other coefficients here. 4 is being left alone. Now, if I had another coefficient somewhere multiplied in, I'd multiply them. Like in number 2, I'll give you a hint. You're going to do 3 times 2. That's going to be your coefficient before you start doing anything with the exponents. But as far as the other ones go, again, watch your base. Make sure the bases that you are putting together are the same. Okay, x to the 2 plus 4 is x to the 6th. With my y's. Colors, I'm going to keep suggesting. Highlighters I've seen people doing, colors, anything just to make things pop. 3 and 2. 3 plus 2 is 5. These are not the same base. I cannot put them together. That's all I can do. So again, if I were you, pause me here for a minute, try out number 2, and then unpause me to see how this goes. All right. Here we go on number 2. 3 times 2 is 6, because again, 3 and 2 coefficients are not exponents. Do not use the exponent rules and add them, okay? Different set of circumstances. X's, 3 plus 4 is 7. Y's, 5 plus 3 is 8. And we're in business, okay? Not bad, just got to get used to them a little bit. Power of a power. Again, we're going to be multiplying the exponents. As simple as 3 times 2, x to the 6th. We're good. Number 4, same thing. And if you want to keep pausing me, one last chance here before I do it. 5 times 3 is 15. Okay? So we just got to keep rolling with that.
Schreiner, please call extension 2314. Corey Schreiner, extension 2314.
So as we continue to keep rolling here, okay, power of a product. Now, very similar except for one small difference. Now, there may be multiple things in here. You're like, wait, what did you just do there while you were talking? I always like to put exponents on things, whether it's a variable that doesn't have one or a coefficient that doesn't have one, because now, when I go through to do my distributing, I don't forget that this gets it too. Sometimes people just see the exponents and that's the only thing that they want to do the multiplying by. But these count too. So 1 times 3 would be 2 to the 3rd. Notice I didn't mess with the base. It's just the exponent. X to the 4 times 3 is 12. And typically we're not going to leave it this way because like 2 to the 3rd, I can actually get a solution, especially when you're doing the online stuff parts, they're going to want you to simplify this. So 2 to the third, your calculator or your brain, 2 times 2 times 2 is 8. X to the 12th. We're good there. And then again, whether you pause me or not for number 6, that 4 exponent is going to be multiplied times each of the exponents on my different bases. And again, is it wrong if I have it this way? No, mathematically you haven't done anything incorrectly. It's just going to be getting that simplified down so what you have matches answers, whether it's on worksheets or on any of the websites. Okay? Power to power, multiplying exponents. Multiplying, add the exponents. You got to keep flipping back now and then to see the properties. That's fine, not a big deal. Negative exponents. Okay, here's Hardy theory. Okay, me with negative exponents, I like to flip them right away. And the reason for that is it keeps me from having to avoid having negative numbers later. What you do is up to you. I'll show you 2 ways on number 7, and I'll kind of let you decide here. So some of you are going to say, okay, so if we do the Hardy flip right away, x to the third is positive, y to the negative second is negative. So I'm going to flip it down to the denominator. X to the fourth is positive, y to the sixth is positive. So now what I would do is I would take each of my, excuse me for a second, I had to move my camera, same bases, okay, x to the third times x to the fourth, you add the exponents, x to the seventh. And then my y's, y to the sixth and y squared, we're dividing, which is subtraction. Bigger minus smaller. But the bigger exponents in the numerator, more on that in a little bit, and we're set. If all your answers are in the numerator, you don't have to put anything in the denominator. I mean, you can put a 1. It wouldn't be a bad thing. But again, when you're doing things online, it's probably just going to have them this way. So you're like, well, what if I wouldn't have done the flipping right away? Okay, if I wouldn't have done the flipping, I'd still had 3 plus 4 is 7. And negative 2 plus 6, because I'd have been multiplying, you can do this, negative 2 plus 6 is 4. You're like, well, that's easier than that was. Sometimes it will be. Sometimes it will be. Other times it won't. It just depends on how you want to do it. Okay. So 8, I'll go straight forward. I won't do flipping right away. Well, you kind of can make your own decision this way. So 2 minus 5 is negative 3. We have to watch our signs. The 5 is bigger, hence y gets negative. And y to the negative 3 plus 6 is y cubed. Now, I can't leave it that way, because remember, on our last page, we talked about no negative exponents in answers. So I got to fix this. Biggest thing people screw up here is this. That negative 3 is only on my x. It is not with the 7, unless there were parentheses. So 7 has a positive exponent, it states. X does not have a negative x. X does have a negative exponent. Excuse my misspeak. That has to flip. Y does not have a negative exponent. It stays. And I'm done. Or you could have done what I did before and flipped these right away and then did the division rules. It's all in how you want to take a look at it. 0 exponent. Here's the thing mainly to look at here. If you see something to the 0 power, I usually will do this. Okay, that equals 1. I don't even want to get confused with what could happen there. Okay, so here I look, I got one coefficient 3. That's my only x left now, so x squared. And then I'm multiplying my y to the thirds, which means I add. And we get that set. Well, wait a minute. What if the whole thing is to 0? If the whole thing is to 0, because if I distributed it, what would happen? I'd have 3 to the 0, which is 0. I'd have x to the 3 times 0, which is 0. which equals 1. And I have y to the 5 times 0, which is 0, which equals 1. Okay? So again, if everything's in parentheses, that whole thing, whatever's in there, is going to turn into 1. It makes a difference. Quotient of powers. Subtract your exponents. Okay, here's where we're going to get to see some e's come into play. 5 minus 2. Okay, 5's the bigger number. So my x to the third stays up in the numerator. Okay, y's. 3 minus 2. 3 is bigger. It's up in the numerator. Get my answer. Take a breath here. Now 12 is the one that gets a little more interesting. Okay, I'm going to give you two options. I know some of you hate this, some of you think this is the best thing ever, so we'll see. Okay, so option 1, we're just going to follow the rules. 4 minus 1 is 3, bigger exponents on top, x to the third. Okay, 2 minus 5 is negative 3. Okay, I'm just subtracting, numerator minus denominator, that's it. But I have a negative exponent, can't have a negative exponent. So x to the third gets to stay where it is. Y to the negative third, negative attitude, not behaving, has to flip. Once we have all positive exponents, we're good. What I like to do with negative exponents is this. So let me rewrite the problem here quick. Is I always like to go looking for the bigger exponent, and I circle them right away. So with the x's, it's here. With the y's, it's here. Here's why I do it. I'm still going to subtract, but I'm always going to subtract big minus small. 4 minus 1 is 3. Where is the bigger exponent in the numerator? That's where my answer goes. Okay? Y. Big minus small. 5 minus 2 is 3. But where's the exponent? It's in the denominator. And I don't have to play the flipping game ever. Okay? So if you do big minus small, just take note, where is the bigger exponent? And that's where your answer is going to be. So it's going to save you a little bit of time and effort and hopefully avoid some of the negatives and stuff. Just something to ponder. Okay. Power of a quotient. Again, if you see things that don't have exponents, give them 1. Just to remind yourself, ooh, that 3 when it's going through has got to go to every exponent inside. Exponents only. So I look, okay, so 1 times 3, because again, we're multiplying the exponents. 1 times 3 is 3. 1 times 3 is 3. And 5 times 3 is 15. Now again, mathematically wise, I'm good right here, but we want to simplify, get into that habit. If you've got to go to the calculator, there's nothing wrong with that. 3 to the third, 3 times 3 times 3 is 27, x to the third, y to the 15th. Different bases, you're done. If they were both x's, I keep going. If they're both y's, I keep going, but not for that. Same thing on 14. Every exponent gets some of the 4. 1 times 4 is 4. 3 times 4 is 12. 6 times 4 is 24. And 2 times 4 is 8. But this time I notice a couple of things. First thing I notice is 5 to the 4th. Oofta, that's kind of a big number. Go to the calculator. Get that one out. This is my only x term, but I have y's. Find your biggest y exponent, 24, and subtract. 24 minus 8 is 16. Bigger exponent is up top. We're in business. So this is going to be more about detail work. Are you willing to take your time and not try to go 100 miles per hour so you can remember the different rules? Okay, combo problems. Love combo problems. Power to power is multiply. But remember, no negative exponents in answers. Don't circle that. If it's got a negative exponent, you flip it. If it has a positive exponent, it stays right where it is. Details. Lots of them. One thing we haven't talked about yet, okay? Again, we talked about how coefficients don't play by the same rules as exponents. That's true here. You'll be shocked, well, probably not. I wouldn't be shocked if this were like, let's say, a quiz question later in the week, and I had a lot of people telling me this is 4, because they're going to subtract. Those aren't exponents. 8 divided by 4 is 2. Okay? Still just 2. 6 minus 4 with my a's, bigger exponent up in the numerator, and there's no other c's. I'm in business. Okay? Again, piece by piece, thinking it through. 17, don't start subtracting exponents yet because you've got these parentheses to deal with. That's one of the few things that we can't avoid. We want to deal with parentheses first when we're doing these. So multiply your exponents up there, not messing it all down here yet. And now we're back to this again. Find the bigger exponent, subtract because we're dividing, bigger exponent, subtract because we're dividing. Okay, no more negative exponents, no more like bases that I can put together. We're good. A couple more to go. I appreciate your patience, but man, it's worth it on stuff like this just to see all the different things that you can run into. So you keep yourself out of trouble. Like here, 5x, the 5 and the x, two different things. They're both getting the exponent, and don't forget your denominator. 5 to the third, x to the third, 3 times 4 is 12. And then again, with the coefficients, try the best you can unless the number's like 6, 7 digits or something like that to get those simplified. Not the same base, do not subtract those. We're good. Then one final one, again, be careful. Okay, this whole quantity to the 0 power, that all turns into 1. 3 times 5 is 15. Make sure the 1 is there because 1 over x to the 15th is different than just x to the 15th. So if you ever have something to the 0, put the 1 there and keep the 1 just to make sure that you're in good shape. Okay, so the practice on this one, you're going to have to skip a page. So let me kind of give you a little guidance here. Because if you flip over, this is another lesson that we're going to do. I believe it's tomorrow. It looks that way. Okay, this is still coming. So what you're going to want to do is flip one more page to where it says practice with exponents 2020. Okay, and again, make sure you have positive exponents. Work through, take your time. There's a key in the back, but you should have work being shown with this. This should not necessarily be going straight to an answer. At least show me one step, okay? Whether it's distributing here, whether it's combining the like terms here before you get to an answer, but just something, so I know you're not just copying answers. Thanks for hanging through with me today. We'll see you again soon.